Hi guys, let's take a look at collisions. So this is an expansion on what you see in your book in section 6.3. So again, to recap 6.1 and 6.2, we know that in the absence of external forces like friction and air resistance, momentum is conserved. However, kinetic energy is not necessarily conserved in these collisions. So a quick recap, recall that in a collision, Pi, or momentum initial, is equal to Pf, momentum final. And I'm not going to go into detail about the algebra. You guys can review the previous video if you'd like to go more in depth on this derivation. But just know that momentum initial is equal to momentum final. So one question that you can keep in the back of your mind as we discuss change in kinetic energy and collisions is if the force on the truck by the car is equal and opposite to the force on the car by the truck, then why does a small car crumple when it collides with a large truck if they both experience the same change of impulse, or the same impulse rather? Okay, moving on. So here we have three different types of collisions, and these examples of the green car and the orange car below each type of collision are not examples of how these collisions happen. Meaning, if you look at the first type of collision, inelastic collisions does not mean that the second mass or the second car is always at rest. This is just an example of how you would go about solving these collisions. Okay, so they can happen in all different types of situations. You could have car 1 at rest and car 2 accelerating. You could have car 2 at rest and car 1 accelerating. You could have both of the cars accelerating towards each other for each of these cases. Okay, so the examples listed below, the types of collisions, are not particular to that collision. These are just examples. So for inelastic collisions, and I'm trying to enunciate here, inelastic collisions, kinetic energy is not conserved. So there is some loss of kinetic energy. So although momentum is conserved, initial momentum equals final momentum, initial KE does not equal final KE. In space elastic collisions, okay, so inside of elastic collisions, kinetic energy is conserved. So momentum is conserved and kinetic energy is conserved. So momentum initial equals momentum final, and kinetic energy initial, which is what you see written out in the black equation underneath the example, kinetic energy initial equals kinetic energy final. So you can go about solving the elastic collisions in two ways, not just one way. Perfectly inelastic collisions, that name is a bit misleading because here you would think that all of the kinetic energy is lost, and that's not what happens. In perfectly inelastic collisions, the two objects stick together and their final velocity is the same. So what you see written here in the black for the equation is that kinetic energy initial is not equal, is not equal to kinetic energy final. However, in every single one of these cases, outlined in purple, every single one of these cases, momentum is conserved. So you could always solve equating momentum initial and momentum final. And in some of these cases, you can solve saying kinetic energy initial equals kinetic energy final. You might oftentimes have to use a system of equations if you know momentum is conserved and kinetic energy is not. And you will see some examples of that as we continue to move through the chapter and advance to our practice test. Mahalo, guys.